All right, last lesson, blue light on. Okay. All right, so symmetry and transformations is the last topic. This is a topic that you will definitely develop a whole lot more in geometry. And by the way, if you notice, we went from 12.5 to 12.8. My recommendation is that every student in here read the text of 12.6 and 12.7. That's what you should do. Okay. And so you got a night tonight. I'll tell you right now, you're not going to have written homework tonight. You should take advantage of that and read 12.6 and 12.7 tonight. The text in the book isn't long. It's usually like 2 pages at most. So read those. We just don't have time to spend in those topics. That doesn't mean they're not important. They will come up again in regular geometry when you get there as 9th or 10th graders. But you should read it yourself. All right, 12.8, symmetry and transformations. What is a transformation? Well, a transformation, you know, you guys are the Transformers generation and stuff like that. I guess don't think of it that way, because in geometry, a transformation is the movement of a shape to another location. It's the movement of a shape to another location. So you can see down below here, you got a shape here, and you got the same shape moved to another location there. So we've got a shape moved to another location. Austin, why don't you just grab? Okay, thanks, John. Right, the shape is moved to another location. We also have it here, right? These two shapes are exactly the same size and shape. They're in 2 different locations. That's a transformation. It could be a triangle, could be an octagon, could be a regular dodecagon, could be a heptagon. It could be a polyhedron, whatever that is. It could be a parabola. It could be an ellipse. It could be a hyperbola. It could be a ray. It could be a line. It could be a line segment. It could be an angle, as you see here. And any other kind of shape. If you take a shape exactly as it is and move it to another location, that is a transformation. So it's the movement of a shape to another location. Believe it or not, this is seemingly shouldn't be the way it is, but this is the way it's termed. The original shape is called the pre-image. That should be read. Called the pre-image. I don't know if in art you've ever taken a picture, and then have you ever done in art where you take the picture and you put squares, a grid across it, and then in the grid, you can either enlarge it or, well, that would be an enlargement or reduction. But if you've ever taken an image and moved it, then that would be the concept, all right? Believe it or not, the original is called a pre-image. Before, I don't know why they want to do it. If I were naming it, I'd call the original the image and the next one the post image or something, but that wasn't me. Somebody who decided that the original is the pre-image. The transformed shape, I'm going to write in green, is called the image. And I guess maybe you could think of it this way. If I took a picture of the class, should have done this because with technology we can do it, and projected it up on the screen, would you actually be the ones on the screen? Well, the likeness of you would be on the screen, but you're not actually on the screen. You're sitting in your seats. So what would be on the screen? The image of you, right? And you're the original, and it's the copy, and the copy is the image. You would be the pre-image, right? That's just the way it is. Don't get those mixed up. Pre-image and then image, not a big deal. How do we designate? The transform shape is called the image. Its vertices receive an apostrophe. An apostrophe. So it can be identified. So the image has the apostrophes. So now go back to your illustration on your sheet there. You don't need to circle them. I'm just trying to focus your attention. Isn't it very clear then which one is the image and which one is the pre-image? It should be. Remember, the pre-image is the first one. The movement to a second location is the image. The one on the left is the pre-image, and the one on the right is the image. How do I know that? What told me that's the way it went? Andrew? The apostrophes, because the image, the one that's moved, always has the apostrophes. And you can see that as well with the angle, right? This one is the original, right? The pre-image. And this one is the image. So the apostrophes let you know which one's the transformed shape. And remember, what does transformation means? What does it mean? It means move that shape to another location. Any questions on that? Just terminology. So transformation is to move an object to another location. The original is called the pre-image, and the one that is moved is called the image. How do you designate the image? Give each vertice, each point at a connection of line segments, an apostrophe. That's how you do it. Or if it's an angle, each point designated as an apostrophe. All right, so that's the idea of transformation. Not a big deal. Although I will tell you this, when we even get into algebra next year, we'll learn how to transform lines. We'll even learn how to transform some other kinds of graphs, and we'll use that concept of moving it to another location. So it's good to get that in your mind right now. All right, I think you know what this next one is. We're going to fill it in a minute, but it's when every point of the pre-image is the same distance from the line of symmetry. From the line of symmetry as the corresponding point of the image. Okay, so look below. We'll fill in the word in a moment here. This is the pre-image, right? The original. Now this you can write in, and this line is, or you can just draw, this line of symmetry is right there. The green line right there is the line of symmetry. You should put an arrow to that so you realize that. And then the shape on the right is the image, right? And we know that because of the apostrophes. So if I were on an overhead projector, which I wish I were for this, I would simply take a ruler out and I would measure all of this. Well, I'm going to measure in a little bit different way. Don't do this. But I'm going to draw a line from here to here. Okay, I'm a little bit over because of the electronic pen, right? Let me get this a little, well, it's high enough. So I'm going to take this line now, and it should be the same distance here. And look at that. Point A is the same distance from the line as point A prime. By the way, these lines are always perpendicular here to the line of symmetry. Okay? I'll do another point, point B. So again, it would be perpendicular. This should, come on, give me that one. No, got to talk to it. Got to coax it. And if everything were right, that one would be the same distance away, right? And same with C. C would be the same distance away. Looks like I'm a little over again. But you can see that sure enough, that's the idea. Okay? And again, please understand, I didn't want to write the perpendicular symbol every time because it would have been harder to capture the line. But it's always perpendicular to the line of symmetry to the vertex. So what do you call that? What is that when you take a shape? It was like this. Watch my hand. The left shape, you take it, and it ends up like that. What is that? Nick? It's a flip, but technically, what is it? Connor? Not a rotation would be like this. Watch. right? Like this or like this. All right. That would be a rotation. Yeah, somebody way back. Thank you. Lauren? Okay, mirror would be a term. We have another term for mirror is reflection. Mirror and reflection, same concept. So yes, it would be a mirror, technically a reflection. And we use both terms in algebra to mirror a shape or reflect a shape. In the Science Center in Cleveland, Ohio, they've got a wall, and you stick your nose right up against the wall, and so the wall goes this way, and this side you're like at a corner. Okay, so you got the corner of the wall, and you stick your nose, and you can look with the one eye down the wall to a mirror. And the mirror down the road gives you a reflection of your face, so you're really only seeing half of your face. But, well, only half of your face is visible. But you know what the mirror does? It gives you the reflection. It takes this half and shows you it, but also shows you the reflection of this side the other way. So you'd look exactly the same, wouldn't you? And the answer is no. Because you know what? We're not perfect. And the left side of your face isn't exactly like the right side. Now, you do have, some of us part our hair, so that would be different, but Wyatt doesn't. And if he, his hair looks exactly the same both sides. If he did that, his one side would look a little different. But it's a mirror image. Hey, when you look at yourself in the mirror, right, you're reflected, you're reversed, and that's the situation going on here. It's a reflection. Jordan. Reflection is what I want you to put. All right, so here's what I want you guys to do for your notes here to illustrate this. Take your red, draw a perpendicular line from A to the line, and we're just going to call it X, and then go from the line to A prime and call it X, meaning they're the same distance, right? And again, we'll put the perpendicular symbol in there. Do the same thing with B. We'll call it Y, and to B prime, and we'll call it Y, showing that they are the same distance. And then finish off with going to C and going to C prime, and we'll call those Z. Both are Z, both are the same distance. Okay. Now it kind of looks like a prism. All right, so how would you reflect something? Now this one, we are actually going to reflect and rotate. So B is a reflection and rotation. If perchance you have a protractor with you, your protractor is really what you want to use on this. Mine's a pain to use. I don't know. I'll see if I can, but it's a pain. What you got to do is I can't even see it. So little. Make it bigger. I can see it better up there than I can here. You want your protractor to be at 90 degrees to your line of symmetry, and then you want to line it up, and I'm going to go with point N. Do you see that? Now, does your protractor have a scale on it? If it does, and you can measure the distance, I'm going to use a line for mine because I can't measure. So I want to go from N to right there, right? And I would measure that with my protractor. For me, though, I'm going to do it this way so I can put that amount right here. And there's my new point. And what would I call my new point? Say it if you know it. No. N what? N prime, right? N with the apostrophe, right? And now I'm going to move up to R. And I'm going to erase my N line. If I can get to my X out. Okay. Erase my N line. And I'm going to figure out the distance. Don't move the protractor. So again, I'm going perpendicular distance from R to my line. Again, hard to do electronically, but you're going to use your protractor to measure. That's a little bit of a crooked line, but that's the idea. And here's my second point, and this is R prime, right? And now I got to do the same thing for Q. No Optimus prime, unfortunately. Boy, that is crooked as can be. But I ended up in the right place, so. And now we're at, what is that, O prime? O prime. Forgot to erase my other line. I'll get rid of it now. And last but not least, and can I get it without changing, I hope. So again, you got to keep your protractor at a 90-degree angle to your line of symmetry. That's T prime. Okay, and the way you're going to finish off is you got to connect the dots. If you have a protractor, use your protractor because you can get it nice and straight. Use your protractor as a straight edge. But it falls right with the world. This will look like the shape. Not the greatest. This one should have been a little bit wider. And again, the more accurate you are, the more careful you are. If I wasn't on an electronic device, it would look better. But it's mirror imaged, right? It went from this to that. And not only that, it rotated a little. So what makes the rotation when your line of symmetry isn't perpendicular? Makes it rotate. It used to be you do these kinds of things in art. Nowadays, everything computers do it all. And just computers are able to do all kinds of reflections and stuff like that. Again, if you had a nice protractor, hopefully yours looks better than mine. Questions, Jack? Just ask me a question. Don't teach the class. What's your question? If you put the line straight, you're going to flip it and get the mirror image, like this one. Right? Here the line is straight, but notice it's flipped. In this one, this part's pointing out. In this one, that part's pointing out. It's not the same. It's mirrored image. It's reflected. Okay? So when you do it straight, you get the mirror image. When you do it, the line of symmetry at an angle, you'll not only reflect it, you will rotate it. Any other questions on that one? Okay. Hopefully yours look better than mine, but then you knew already I had no artistic ability. Yeah, might as well just get rid of my shade. All right, the last thought is symmetry. A figure has a line of symmetry if and only if each half of the figure is the, and you could say reflection, but that's not the word we're going to use. We're going to use image. Is the image of the other half. So we've got some examples here. Just trying to focus your attention. Right here, the line of symmetry is this line right here, right? That's the line of symmetry. And the left side and right sides are mirror images, reflections. Do you agree? In the next example, however, the next tree there, that tree's not symmetrical. Does the left side look like a mirror image of the right? Oh, they're close, but they're not the same. That's called asymmetrical. Okay? They are not symmetric. And not everything is symmetric. There's sometimes more than one line of symmetry. Here's a couple more examples. The letter A, right? Your line of symmetry would go right through it like that. Now the left and rights are mirror images. The letter E, though, you're going to have to take it that way to make it be a mirror image. How else are you going to get that to be mirrored, right? No other way works. If you go like that, is the left the same as the right? No. And you can try to get creative maybe and go like that, but that still doesn't work either. And the only way is going the way the line goes. Now, if you look at the oval here on the right, to be honest with you, there's a number of different ways you can do that one. It shows a horizontal line of symmetry and a vertical line of symmetry. It can go two different ways because of the shape. Letter H can have a vertical line of symmetry or a horizontal line of symmetry. And maybe even more on that one. Can you go this way? Right? Doesn't that work for an H? Yeah, I think that's mirror image. Or you can go like that. So there's more than one way to skin that. How about this shape? Oh, man. As long as you go through the center point, I think you're going to hit a line of symmetry, right? So there's a lot of ways you can go through that. Here, you can see the triangle with numbers of lines of symmetry, the square with numbers of lines of symmetry. Look at the star. You can not only go along the point to a non-point, but you can do that all the way around. And so there's a bunch of line of symmetries right there. Okay, so we got 5 shapes. Go ahead and draw. Each one of these shapes has only one line of symmetry. If you want to do it in pencil, do it in pencil. If you're confident, go ahead and do it in pen. Draw the line of symmetry for each of those 5 shapes. Again, I believe, well, one of them I think can go 2 different ways. One of them has 2. I think everything else has just 1. One of them can go 2 different lines of symmetry. Draw them both if you can. The rest only have 1. Lines of symmetry. While you're waiting for everybody else to finish up, open up page 540. I'm going to try to get a few of these in for the last couple minutes. As I told you, I'm not giving you homework over this. Can't be 540. No. You know what? Maybe I did figure homework for you guys. I may have figured out chapter review. I think I did. Yes, I'm sorry. I did. All right, I'll show it to you in a minute. Don't worry about your books. All right, for time's sake here, line of symmetry. That one's easy, right? I do dotted lines. You could have done a solid line, right? Right down through the butterfly. The heart is the same way. Right down through there. The only way to do the arrow is to go this way. Who's 3 for 3? Okay. Actually, this blue shape, you could go like this. That's one of them. You could also go like this. So there were 2 on the blue one. And because of the face on the smiley, then you can only go dead center, right? Lines of symmetry. All right. Let me check at the end, but I'm pretty sure I decided to give you chapter review. Page 540, 9 through 17, 21 through 23, 25 through 27, 31, 32. 9 to 17, 21 to 23, 25 to 27, 31, and 32.